I believe that by now we are all familiar with the networking utility ping, which verifies reachability to another host. And yet, we're all guilty of visiting google.com to verify internet connection. In both cases, the user provides either the name, which DNS translates to an IP address, or the IP address itself. But for full communication, we need MAC address destination too. Who provides that? That's when ARP comes in play, Address Resolution Protocol. Let's look at how it really works. Let's build a small network on Packet Tracer composed of a switch and 3 computers and assign some IP addresses so that they can communicate. There is this simulation tab right here, which is a fantastic tool that allows you to see what's happening in your network, and you can select the protocols that you'd like to monitor. In our case, we're only interested in ARP and ICMP, which is the ping protocol. It's better to deselect the others so they don't bother us. There are too many here, so it's better to click select none and only select ARP and ICMP instead of deselecting each one by itself. Let's ping from this PC using the IP address and see what happens. You can see that it generated 2 messages here. One is our ping, colored whatever that color is, and the other is ARP. If we examine the ping message, we'll see that it knows the IP source because it's his, and the IP destination because we provided it for him. But notice layer 2 is empty. It doesn't have enough information to construct a full frame. So it asks what is the MAC destination corresponding to the IP address it's trying to reach using Address Resolution Protocol, ARP. But ask who? Let's examine the ARP message and find out. You can see that the MAC destination is all F's, making it a broadcast frame. And it got his MAC as a source and his IP as a source, and the IP is trying to reach as destination. Basically, this ARP request is like a shout from this PC that says, whoever got this IP address, I need your MAC address so I can send you something. Here are my MAC and IP so that you know who I am and you can reply back to me. Oops. If you click on this real-time tab, the whole ARP process will quickly happen in the background and we won't be able to see it. So what I'll do is I'll copy paste the whole topology and repeat the process on these. Go to Simulation tab, ping 10.0.0.3, and you get an ICMP and an ARP. So the ARP will reach the switch. Since it's a broadcast, it will forward it to all his active ports, except from where it got it from. Typical switch behavior. This one right here will get it and think that's not addressed to me because it doesn't match my IP address. And this one will say, oh, someone is requesting my MAC address, let's reply back. If we examine this reply, we'll see that it is a unicast and it has the MAC and the IP destination of this machine. So the switch will forward it to the right destination rather than broadcasting it like it did with the request. Now the PC got all the info it needs to perform a proper ping. If we examine it, we'll see that both layer 2 and layer 3 have the correct addresses. Here is the reply from the ping, and you can see that it is a success. By default, there are 4 ping requests, and this is just one of them. You can just resume the process to see the other ones. You can speed up the process in here. The other ones didn't require any ARPing because it was already resolved and they are all a success. The information that we collected using ARP is kept in the ARP cache table within the PC. If you type in ARP in the command prompt, it will show you the options that you can use. ARP-A displays ARP entries and you can clear it using ARP-D. Display again, no ARP entries found. Before we wrap this up, let me ask you this. Well, first let's raise the stakes a bit and add a router so we can have another network and assign IP addresses and stuff. If you're not sure about addressing, don't worry, we'll get to that later. Let's start with the router's interfaces. I'm cheating a bit here. We'll go through the commands in greater detail later. I'm going to assign the 8.0 network so we can pretend that we have Google's DNS server here, and add the default gateway, which will be the router's interface. As we've seen previously on both of our LANs, add our bogus DNS server too, just for show. Again, if you're unsure about what I've just done, it's okay. For now, just think of these two LANs as separate networks. If any of these PCs try to reach this server, whose MAC address they'll need to know. If your answer is this router, you're right. And if you thought otherwise, then I suggest you watch part 5 of this series, or you can build a topology similar to this one and use the simulation tab and investigate what is going on. It's really a good skill to have. Before we ping, let's look at the ARP cache. It has no entries. Then ping 8.8.8.8. There you go. Good boy. Let's look at the ARP cache again. You see, the router's address is the one that got resolved, which is the default gateway. If we put the wrong default gateway in here and then ping again, it won't work. All the pings will time out. And yet, look at this. The ARP of the wrong default gateway got resolved instead, because we told them that that 3 machine is the way out of the network. Okay, let's put back the correct default gateway. Oh, and the reason why this first ping timed out in here is because when this router tried to forward the ping, it needed to do its own ARP request to find out the MAC of where the ping is going. We've seen that it's a broadcast and this one will drop it. This process took a bit of time and this machine got tired of waiting for a reply and it sent a second ping. By then the ARP got resolved and this server didn't need to do any ARP as it already got the router's MAC cached in when it received the first ARP request from the router. So we replied back to the ping that follows. This was an introduction to ARP, Address Resolution Protocol, which basically fetched a MAC address that corresponds to an IP address using broadcast. I hope this has been informative for you. If you have any questions, you can leave them in the comment. I'd appreciate if you subscribe too, and thank you for viewing.